I'm sorry about that. But taking the reactants from the slow step, we have these reactants. We are left with these reactants, C2H4 gas and HCl gas. This, you plugging in for the rate law formula, this is what you have. Then ID an intermediate in the reaction above. I was thinking about when I highlighted it that I shouldn't have highlighted it all, and here's why. So, give me a sec. So, rewriting this for reasons, this is your answer. So, not to be confused with this is not part of your answer, but just to explain it, a intermediate is something that gets used up, that's formed and used up immediately. So, this reaction is occurring like it's ongoing. It doesn't form these hang around for a little bit and then this reaction happens. So this reaction happens, and then this reaction happens. As soon as these things two can meet in whatever space they're in, they then form this, right? So what are the products of this reaction are going to come together to form this reaction? And an intermediate is not going to be part of this. So out of the reactions in here, it's going to be used up to form this. So as you can see, both of these are intermediates because they're formed here, but I mean, they're missing here. There's nothing there. So these both are, but since it asks for an intermediate, you just have to put this. So aluminum metal can be recycled from scrap metal by melting the metal and evaporating impurities. Calculate the amount of heat needed to purify 1 mole. So this problem, you can see I put a lot of given down. So this is really important because you can identify that it's giving you all the information right here. You just have to know what the information is. So the amount of aluminum is 1 mole as stated right here. The original temperature is 298 as stated right there. The final temperature is 833 K as stated. Sorry, not final. The melting point. The molar heat capacity of aluminum is given to you. So what I would recommend is don't write down all your givens. You don't need to do that. Just highlight them, because you don't need to be I don't need, every time I'm trying to find something in the answer, I don't need to reread calculate the amount. Now remember, it is important to note that since it says calculate the amount, that has to be in your answer. So you need to include your formulas and your steps of calculation to get full credit. And lastly, it gives you the heat fission. I've just color coded. Okay, so the two formulas you can, from all this information, the two useful formulas are Q equals C equals N CP delta T, and Q equals N delta H thus. So the first thing we need to find is our missing values. So we don't have delta T. So delta T is just the change of T over time. So you need to get that so that you can make sure that you can have that. Now you can just plug them in. So this is where being able to identify that N is moles, that this CP is 24. As stated, it's molar heat cap. And we just did the delta T. So plugging this in for the formula and then dividing the answer you get, because it's just in J and you need it in KJ to make it 15.24. Because when we're plugging it in right here, we need it in that. Sorry, we're not plugging this in for here. When we are minusing, we need the same values, and it expects our answer in KJ. Q, then we can just plug it in. 1 times $10.4 K, sorry, gives us it right here. So knowing that this, the heat fusion, this just means delta H pus, sorry, not pus. Total, then calculating for total heat, which is what it asked us, the amount of heat needed to purify. We're just gonna minus it. Sorry, we're just gonna plus it, giving you a total answer of right there, 25.94. I would be a terrible teacher. This is crazy. Okay, we have a little bit more. The equation for the overall process of extracting Al from this is shown below, which requires less energy. Recycling extracts Al. Yeah. Okay. We are asked which requires less energy. Extracting it, recycling it, or extracting it, and justify it with the calculation. Now, this value right here, we get from here. Wait. Sorry, yes, we get it from here. The question, the aluminum metal can be recycled from scrap by heating the metals and evaporating impurities. We are given the total heat of the evaporation is what we're asking, what it's asking for, which requires less energy, aka less heat. Like, we're not, which one are we going to add less heat to is what it's asking. So this formula, which is given to you right here, and then this, make sure you keep that in mind. So we are given from this the energy to recycle 1 mole of Al. Now the calculation we need to make is extracting it. So this is where, you really got to have stoichiometry geometry on lock. The energy per 1 mole of Al is going to be the delta H. And this is supposed to say, it's not supposed to be JJ. It's supposed to be KJ. this over 2 because we have 2 moles of the substance. So this is going to give us this, which you can, recycling Al cost less from extracting it because the number we got here and the number we just got.